Topic 1.1 notes. So topic 1.1, first of all, topic 1 is an entire chapter devoted to linear functions and systems. In topic 1.1, we're going to introduce you to key features of functions. And by the end of topic 1.1, you would be able to interpret the key features of different types of functions, linear, quadratic, absolute value, and analyze features of those functions. So you see at the top, all of that vocabulary you are going to learn in topic 1.1, and it's a lot. So we'll spend a couple days on this. In order to be successful in topic 1.1, we have some prerequisite skills that we want to focus on and have you practice, and then we'll jump into the new material. So we begin with function notation. So what is a function? A function is a relationship where there's a rule and you have an input that you put into that rule and apply the rule, and out comes the output. So we have inputs and outputs when we work with functions. Function notation, f of x, means the function evaluated for a given value of x. And that value can change based on the type of function it is. For number 1a, when it says given f of x equals 1/2 x minus 4, what is f of negative 2? This means that we would take that negative 2 and we would replace it wherever we see x in the function rule. So f of negative 2 would be 1/2 multiplied by negative 2. So here's where we're going to replace negative 2 where the x is. Subtract 4. 1/2 times negative 2 is negative 1. Negative 1 subtract 4 is a negative 5. So we would say f of negative 2 is negative 5. Negative 2 is the input to the function. Negative 5 would be the output of the function. So we would say the function evaluated at negative 2 is the value negative 5. For 1b, you see that the variable x occurs twice in the function rule. So that means when we evaluate f of negative 1, wherever we see x, we input negative 1. So f of negative 1 would be 2 times the quantity negative 1 squared. And notice I'm putting parentheses around it because the input is negative 1 and we want to square it. And so we're going to use parentheses. Whenever your function rule has exponents in it and you evaluate for a given value, put parentheses around the input. Minus 3 times negative 1 plus 1. Now we're going to evaluate. So it's going to be 2 times a positive 1. Negative 1 squared is a positive 1. Minus 3 multiplied by negative 1 is going to be plus 3 plus 1. And so that's going to be 2 plus 3 is 5 plus 1 is 6. So we would say f of negative 1 equals 6. And that is evaluating functions. The second prerequisite skill is graphing functions. And whenever you graph functions or equations, one of the most efficient ways is to use something called a t-chart. And a t-chart is kind of doing what we did up at number 1, where you select some inputs to the equation or the function, plug it in, and get your output. And then those inputs and outputs translate into points that are on the function or the equation. In this case, in 2, we have it written as y equals 1/2 x minus 4. And if you look up in 1a, it was f of x equals 1/2 x minus 4. And the only difference between those two is one of them, 1A, is using function notation, and the other one is just using regular linear notation. That is actually the equation of a line. All right, so let's pick some points. Let's pick some x values to use as inputs. And so I'm going to pick -6, -4, -2, 0, 2, 4, 6. Now that might seem like a lot of inputs, right? But maybe you'll only get through a few of them and you will be able to complete the sketch of the graph. Maybe you will need a lot of them in order to determine what the graph looks like. So that means you're going to plug in -6 over here where you see x. So I'm just going to highlight the x over here. And each time you're going to plug in the x value and you're going to have a corresponding y value. So again, I'm going to remind you, we call this an input because we're putting it into the equation, and this is the output. So -6 multiplied by 1/2 is -3. -3 subtract 4 is -7. 1/2 times -4 is -2. -2 minus 4 is -6. 1/2 times -2 is -1. -1 minus 4 is -5. Now you might think, why did I pick -6, -4, -2, 0, 2, 4, 6? Well, when I looked at the 1/2, I don't want to try to plot points that are fractions. So I thought of numbers that when I took half of them, I still got an integer. And so that's why I picked those even numbers. 0 times 1/2 is 0, minus 4 is -4. 2 times 1/2 is 1, minus 4 is -3. 4 times 1/2 is 2. 2 minus 4 is -2. And 6 times 1/2 is 3, and 3 minus 4 is -1. All right, so let's plot those points. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5. 0, -4. 2, -3. 4, -2. And 6, -1. Now, maybe you remember from geometry or algebra 1 that the number in front of x over here is called the slope of the line, and that's rise over run. So if you look from this point to this point, you see that you go up 1 over 2, up 1 over 2, up 1 over 2. And that is, in fact, the slope of that line. And that's how you graph. Inputs, outputs, take those, translate them into points on the graph. Two features of graphs that you have learned before in the past are x and y intercepts. Your x-intercept is where the graph crosses the x-axis. So I don't actually have that point, right? So if I go from here, from the last place we left off, and I go up 1 over 2, that's going to land me right there. And the location of that point is 1, 2, 3, 4, 5, 6, 7, 8, 0. So the x-intercept is where the y value is equal to 0. So you can graphically determine the x-intercept, or you could algebraically determine it by taking the y value of the equation and replacing it with 0 and solving for x. Your y-intercept is where the x value is 0. Now, in the equation of the line, you might remember that that's your y-intercept. Like maybe you remember that from prior math. Okay, so the y-intercept here, and it also was in the table. See over here in the table? So the y-intercept is 0, -4. The y-intercept is where the x value is 0. All right. The third prerequisite is a review on inequality symbols, solving inequalities, and number lines. So here's a refresher in your symbols. So greater than or equal to, less than or equal to. The difference between the first two is that it includes the value. So if we said x greater than 2, that means every number that's starting at 2 but not including it. If we said x greater than or equal to 2, then we're saying, okay, include 2 and then every number that is larger than that. So that's the difference between the underline there. All right, so let's review solving. So when we solve an inequality, we solve it like we're solving an equation. And one thing to remember was that if you multiplied or divide by a negative, the inequality symbol will reverse. So 4x plus 1 less than 9, I'm going to subtract 1. I'm solving for x. So that's going to be 4x less than 8. And now I'm going to divide both sides by 4. Notice 4 is a positive number, so this results in x less than 2. What does that look like on a number line? Well, all the numbers that are less than the number 2. No underline there, so we're not including 2. So open circle, and everything less than 2. So obviously 1 is less than 2, 0 is less than 2, -1 is less than 2. Open circle indicates on the number line that we are not including the number 2. All right, let's try the next one. So we're going to distribute, because remember we're solving for x. So that's going to be -2x plus 8 less than or equal to 20. So we're multiplying the -2 times the x, and when we multiply the -2 times the -4, the result is a positive 8. Subtract 8. And now when we divide by the number in front of x, it's a negative. And so the inequality symbol switches. So it goes from less than or equal to greater than or equal. Less than or equal to greater than or equal. So I always zero out my number line, probably around, halfway. And then -6 will be to the left of 0. And it's greater than or equal to. So that would indicate that we would have a closed circle at -6. And the graph will represent all of the numbers larger, greater than. And so the arrow will shade to the right. Now, some people actually shade on the number line. I shade above it just so that it's easier to see. It doesn't make a difference. All right. I already talked a little bit about the slope of a line. So the slope of a line is the rise over the run. And it can be calculated using two ordered pairs on the line. So if we have x1, y1, and x2, y2, so there's 2 points on the line. Our slope is calculated as y2 minus y1 over x2 minus x1. So we can actually get a calculation. We can also determine the slope of the line by just counting like I did in that previous example, rise over run. So if I get let's pick a different color here. And I go rise over run, and I count, I can determine the slope or the slant of the line. This line is slanting down and to the right. This line has a negative slope. So if the line slants this way, down to the right, negative slope, up to the right, positive slope. Now, if you're calculating the slope using the slope formula, then whatever you get is going to be positive or negative based on the numbers that go into the equation. But if you're going to use rise over run, you have to remember that the negative slope, the line slants down and to the right. One other thing to think about when you're looking at graphs is when you read a graph, it's the same way you would read a book. So we always start at the left part of the graph and we read from left to right. So if you're looking at that line and you're reading it from left to right, you can see that the line starts up at the top in the second quadrant and it ends, well, it doesn't end, but it keeps on going in the fourth quadrant. So we would say that line is falling. If we're going to do the calculation, then we need the location of those ordered pairs. So that's 1, 2, 3, 4, negative 5, 1, 2, 3, 4, 5. So we've got negative 5, 5, and we've got 2, negative 3. And so if we were to put that into the slope formula, that would be negative 3 subtract 5 over 2 subtract negative 5. That's going to give me negative 8 over 7. So the slope of this line is negative 8 over 7. So let's verify that using the purple rise over run. So 1, 2, 3, 4, 5, 6, 7, 8. And sure enough, that's 8. 1, 2, 3, 4, 5, 6, 7. And that is 7. But again, you have to remember that that is a negative slope. Number 6, interpreting graphs. So again, I want you to think about what I just said about reading graphs from left to right, right? And there should actually be arrows at the bottom of this graph. So if we were to read this graph from left to right, we see that the graph starts way down here in the third quadrant, right? And as I go across the graph, we would say that this graph is increasing, so you can see me tracing in the purple, increasing, increasing, increasing. And at this point right here, the graph has reached what we would call the highest point of that graph. And it turns, and it's no longer increasing anymore, it's decreasing. Now this is vocabulary that we're going to talk about in our key features of functions. For now, I just want you to think about the fact that the graph is increasing up to that point and decreasing. That point actually has a name. It's called the maximum. So this is the highest point on the graph. The highest point on the graph. Your minimum is your lowest point on a graph. Now, in this particular graph, there is no lowest point because those arrows, which you'll have to add into your graph, indicate that the graph keeps on going in the third quadrant. So I keep talking about quadrants. Let me go ahead and do a quick recap on quadrants. Oh my gosh, Roman numerals. So this is the first quadrant. This is the second, Roman numeral 2, third, and fourth. If you actually follow that from 1, 2, 3, 4, it makes a big C. So you're kind of tracing a C. So in the third and fourth quadrant, that graph is continuous below what you see, right? We're just seeing a snapshot of it. So there is no lowest point on this graph because the graph keeps on going down there. So minimum and maximum. So the highest point in the graph and the lowest point in the graph. And we'll talk more about maybe graphs might have more than one maximum point or more than one minimum. All right, number 7. Our last prerequisite skill would be solving absolute value equations. And when you solve absolute value equations, those bars actually mean something. All right? And so when you solve, you end up setting up 2 equations. So let me walk you through the first 2 and then we'll practice one. So the first thing you're going to want to do is you're going to isolate the absolute value and whatever is inside of it. It might be a single variable like in A, and it might be an expression like it is in B. So to isolate it, we would add 3 to both sides. And so that's going to be the absolute value of x equals 12. Now, what absolute value represents is the distance to 0 on a number line. So if you picture a number line, there are 2 places on the number line where the distance to 0 is 12. Most people only think of 12. So 12 is 12 units from 0 on a number line. But if you're at negative 12, you are also 12 units from 0. So let me draw a little picture of that. So draw a little picture of that down here. So 0, 12, and negative 12. So this is 12, and this is 12. And both of them are positive because distance is always positive. We would never say that we traveled a negative 3 miles. So distance is always positive. So when we're answering the absolute value of x equals 12, our answer is going to be x equals 12 and x equals negative 12. So you set x equal to positive 12 and negative 12 because they both represent the locations on a number line right here where the distance to 0 is 12. And that's what absolute value means. I don't know why there's that crazy little parallelogram there. I don't even know how I did that. Okay, B. So for B, the absolute value is already isolated. So what we're going to do is we're going to set up 2 equations because we know that if the distance to 0 is 7, we know that that can occur at positive 7 or at negative 7. So absolute value equations will always be set up into 2 cases. The first case is equal to the number, so equal to 7, and the second case is equal to the opposite. Because again, think about on the number line where the distance to 0 is 7. And that's going to be 2 locations, 7 and negative 7. Okay, now we just solve. So subtract 2, negative 3x equals 5. Divide by negative 3, divide by negative 3. So my first solution is x equals negative 5/3. Subtract 2, negative 3x equals negative 9, x equals 3. So my 2 solutions. So now we have equations that are 2 solutions. When you did the Delta Math review, you worked with equations that had 1 solution. All right, last example to solve. Why don't you go ahead and try that on your own? Pause the video, and then you can come back and check your solution. All right, so we have two solutions, x equals -9 and x equals 16. Now, something I didn't mention before is you can always check your solutions to see if you're right. So if you plug in -9 up here, so let's do a check. I probably should have done a check on those earlier ones. So absolute value of -2. Oh, I don't know why it's doing that. I'm going to go back. Okay, absolute value of -2 times -9 plus 7 equals 25. Okay, so -2 times -9 is a positive 18. Positive 18 plus 7 is 25. Absolute value of 25 equals 25. That one checks. Let's test the second one. And you're testing it all the way back in the original equation. So that's going to be absolute value of -2 times 16 plus 7 equals 25. Okay, that's -32 plus 7, which is a -25. And the absolute value of -25 is a positive 25. And that is the prerequisite skills.